Okay, Professor Lewis here, and we're going to talk about Rockwell testing. And at this point, you should have watched the prep lecture on Rockwell testing and hardness testing and the different scales that we associate with hardness testing. Now, the scales that we're going to be using on this hardness tester is just going to be the B and the C scale. So that means we're going to use the Rockwell C indenter, which is a diamond indenter, and we're going to use 150 kilograms load on there. The B is going to be the ball indenter, and we're going to use the 100 kilogram indenter. Now on this machine, before we turn it on, I want to start and show you that we have a wheel back here that selects the weight that we're going to have associated to that indenter. And to change that, we just turn it back here to whichever indenter we're using. So if I'm using the B scale, I want to read 100. If I'm on the C scale, to 150. And what that's doing is changing the weights in the back of the column here so that it'll put the correct weight to the indenter. Now we want to remember we have a minor load of 10 kilograms and then the combined load to equals 150 kilograms. And so we're going to be measuring the depth of penetration that the indenter is going to go into the part. And so that's what that minor load is we use that as a reference of 0, and then we go in for the final load that gives us that full indentation on there. The other thing we want to point out is when that indentation goes into the material, we're displacing the material, and we're going to have that crater that we talked about, and that's going to put some displaced material up top. So we only want to take measurements on one side of the part again. Now let's talk about the machine here. How do we turn this on? We come back here and there's a switch in the back and we turn that on, and this is an electronic machine and has very sensitive equipment in here in terms of measuring that depth of penetration on the indenter. So we really want to be careful with hitting this top side or hitting the indenter when we're loading and unloading parts or anvils in there. So let's look at our menu that we have up here. First of all, this says that we're on the Rockwell C scale. We can see that because it says it's on a HRC scale. If I want to change scales, I hit HR, and I'm going to see that I have a HRC and a HRB scale. Those are the only two scales we're really going to use for lab here. And you say, okay, and now I'm on the B scale. You notice it's flashing 100 kilograms because I have currently the load set at 150 kilograms for a Rockwell C test. I'm going to go ahead and switch it back to a Rockwell C test because we always want to start with a Rockwell C test before a B test so that we don't tear up the indenter. Remember, we don't know how hard the material is, and if it's harder than the indenter on the B scale, we'll destroy that indenter. So always start with the C scale, and then we'll work our way down if we need to go to the B scale. So the C scale is going to stop at about 20. Now, if we get a 5 or an 8 or a 10 on the value, we can still use that. This machine is going to be okay. It's just I have it set to tell us to use the B scale if you drop below 20. There are some tests that you might need to use a Rockwell C of 8 or 10 on the results that come up. For example, when we're doing the geometry test. But if I'm doing just a single part and I hit a 10 or a 5, I'm probably going to go ahead and want to drop down to a better scale that has better differentiation on the units. I'm going to drop down to a B scale and get more publicized data. A lot of the publications will stop at 20. So we have our HRC, we've got the correct weight, we're not flashing, we have it turned correctly in the back. We need to put our indenter on here. Now our indenter is going to be color coded. Every indenter has a color on it. So this one has a orange dot on it, and that means this goes with this orange dot here on this machine. Every machine has a different color of dots right here, and their indenters are colored differently. The reason is we have different grades of indenters from Class A to Class B. Now Class A is like our calibration, high-end, they're really expensive indenters. Class B is considered our working indenters, and that's what we're working with is a Class B indenter. They're still really expensive and they're really good indenters, but what we have to do is go into the machine, and I've done this earlier, we do this as part of our PM schedule. We go in and certify that the machine is working with this indenter and reading correctly. So we're going to do that, and then we're going to take some hardness test on a part. So we have our C value. I'm going to put my indenter into the machine, and it's going to pop up in there, and there's a magnet that just holds that into place. Okay, so I have my C indenter loaded. Now the gap between the indenter and where the anvil is going to be is fairly small. So I'm going to go ahead and turn this hand wheel down here, and this turns a nut on this Acme screw, which is a power thread, and it's going to lower this down. Now I have two different anvils that we're going to talk about. I've got an anvil right here that is a flat anvil, and if I look at the flat anvil, it's going to have a surface down here that's going to make contact with this surface right here. And I'm going to go ahead and clean this with a rag, and you can go get the towels from the wash area, a white rag, and we're going to carefully, not hitting our indenter. A lot of times I like to put my finger up there as a protector, and I'm going to drop that indenter or the anvil down onto the screw. That is now clean and it's sitting nice and flat. Okay, this is for flat parts. So if I have a part that is flat, like we're going to talk about here in a minute, where we have this A36 piece of steel and we're going to take tests, we're going to talk about cleaning that up here in a minute, but it's nice and parallel from these surfaces, and I can do those parallel measurements. We talked about that in the prep video. The other anvil that I have is this one right here, and this is for the round objects, where I can hold a round object and take it on a hardness test on the top here. Now again, that's a curved surface, so we could have convex, concave surfaces, and we talked about that in the prep video, where we would have to add or subtract depending on what kind of surface we have with our readings on the machine here. So that takes us to, what do we have at the machine here for you guys? We have some laminated copies of correction factors for different diameters and different scales. That's going to help you out. We talked about that in the prep video. And we also have another sheet that has hardness conversions from B to C to Burnell, Vickers, and all that. And this is all coming from the ASTM standard. We talked about that in the prep video. So these are here for you so that if you need to do some conversions or do something, that's going to be really nice. Now, will this machine do conversions? Yes, it will apply all those. We're not going to turn that feature on because we can't remember if we turn it on or off, and it puts in errors into our data. So we're just going to always assume we're taking a flat measurement and we're going to manually add correction factors on. Okay, so how hard is this material? Well, first of all, we need to certify this machine. Is this machine reading correctly? We have what we call calibration blocks, and this is a calibration block right here. I'm going to take it out, and if you notice, I'm going to handle this by the outer edges right here. Don't handle it by the flat surfaces. We don't want to have corrosion or rust happening there. And what we're going to see is if you get it just right, one side is nice and shiny and there's no indentions on that. We only take test on one side. And so this side has little dots on it, okay, that I can see where we've taken previous tests. So this is a consumable. This one right here is set to read at 63.15 plus or minus 1 on the Rockwell C scale. And it's stenciled in on the sample. So I'm going to load this into the machine, and what I'm going to do is bring this up. Now, it's hard to see the previous indentions. That brings us to another cool feature up on the machine. We can turn the light on or we can turn the light off. I like turning the light on because as a user, once I start getting the indenter up there, I can see where the part is in previous indentions and get the correct spacing between those. And so once I get close, I'm going to watch the machine up here, and it's going to have a little bar that moves over here, and it's going to set, and I'm going to feel it in the hand wheel as I turn clockwise slowly. I'm going to feel it click, and it's going to tell me to stop turning. It's going to disengage the loading capability. So we're turning, it clicked, I stop. We're letting the machine test. It's doing its test cycle for 2 seconds, and then it's going to report back. Now, I'm looking for a 63.15. I'm at 62.7. That's the first measurement with this machine. We're going to throw that data out. Everything's just been pressed and seated up, and so hopefully the next test we get will be more in line with what we want. So I'm going to come in here and take another test. And what we want is 3 measurements that are about the same, that average out correctly. If we get a measurement that's way off from another one, we're going to throw that data out. Now we have 63.5. Now we're starting to talk some pretty good data here. I'm only 0.4 off. I'm going to come in here and take another test. And we're at 63.3. So I'm going to do one more test just to see where we're at and go into another clean area. And we're now engaged. We're at 63.8. So this was within the plus or minus 1 on the Rockwell C scale. So I would say this machine is reading consistent. Now, is this something that you guys are going to do in lab? This is basically just verifying the machine is calibrated. It is calibrated. The TAs will do this probably once a day before each lab section and make sure it's working. You know that when you come, our machines will be calibrated and ready for you. If I was going to do this, I'm going to probably do it on the C scale and the B scale and make sure that I'm calibrated on both and they're verified and reading correctly. So we usually do that ahead of time. How do we do this in industry? Industry has an ISO procedure, International Standards Procedure. It says, do you do what you say you're going to do? And so you have to write your own standards. A company may say, we want to calibrate this every time we take a measurement and verify it with the standard, or we're going to come in and do this once a day, every hour, and you would have to have a log that you keep track and write down that you verify this, who did it, and the results from that. So we're not as tight with ISO standards in here, but we want to talk about that this is a calibratable item and that you may want to find out what those procedures are. So we're getting good values from our standard. Now, while we have this in here, I want to know, on the C scale, looking at this, we have a 20 to a 70. 70 is really, really hard on the C scale. And we talk about this as a harder scale than B. And we're going to, when we get down to 20, typically we'll drop down to the B scale. So I have a file right here, and a file is really, really hard. Okay, this is going to be a tool steel, and it's going to be heat treated, and it's typically going to be around a 60 on the Rockwell C scale. So I'm going to put this file in here and bring it up here and just see how hard a file is real quick before we continue on with where I was headed. I'm going to put this file in here, make sure everything is loaded correctly, and I'm going to come in here and take a value. And we're getting a 61.4 on this scale, on this file. So files are definitely up around 60 on the Rockwell hardness scale, pretty hard. That brings us to our part that we're going to do next. We have a piece of A36 steel. This is a tensile sample that we'll use in other labs, and A36 steel is a structural grade steel. The 36 means that it's 36 KSI on the yield. This is a fairly soft and weak material. Now this is a material that you might go down to Stillwater Steel, Railroad Yard, buy some angle tubing, some square tubing, and it's going to be very similar to this, some sheet metal, and we can weld on it, and it's a fairly good steel for that, for the price. Now then, this is coming to us, and we water jet cut this, and we have some burrs that are on the part, and so we're going to go want and deburr that part. So let's go deburr the part. Okay, so we're back from deburring the part, and we've got it all cleaned up and everything, and what we want to do is take a few hardness values on this part. And so I'm going to slide that part into the machine. And one of the things I want to point out is, don't let the part want to fall and think that the indenter is going to keep it falling down over here. You want to locate the part so that it's going to sit in there correctly by itself, and we can take our measurement, because we don't want to put any force. We're only dealing with 150 kilograms. That's not a lot. And so we're going to have our part properly secured. Now I'm going to come in here and raise up and take a measurement on that part. We're on the Rockwell C scale. We said this is fairly soft steel. So the question is, how soft? And the machine's telling us we're at a negative 0.1 on the Rockwell C scale. So it is so low it's not even measuring, and it gave us an X here. That means it's not a good test and a good result value. We're on the wrong scale for this part. So what I'm going to do is lower this down, and I'm going to change indenters. And I'm going to go with the 16th inch ball indenter, because we're going to switch scales. I'm going to load that up there, change my scale to Rockwell B, and we're there. We can see where it be, and it's flashing that the load is incorrect. We don't have 100 kilograms. So I'm going to go around the machine, change it to 100 kilograms, and we're properly set. So I'm going to bring my part back up here, and again, only take measurements on one side of your part. You don't want those divots between the anvil and your part. That's going to give you bad results. We worked hard on deburring that part. So I'm going to come in here, and I'm going to take a value and see what we get. Again, the first value we may want to throw out because we just are seating everything back up properly. And I'm at 83.3. So I'm going to take another measurement. Move over, again, 3 times the diameter. Coming off that standard. Take another value. We're at 83.2. So we're getting some really good measurements that are about the same. If I get 3 measurements that are about the same, which I'm striking around 83 on this thing, on the B scale, then I'm going to call it an 83. And I'm going to call this 83. So the Rockwell B 83 for A36 steel. That tells us how to use this. So I hope that helps you out.